Hello, Climate Tech crew, and welcome to another episode of the Green New Perspective podcast, your go-to place to learn about innovations happening within clean tech, nature tech, biotech, and agri-tech space, and to get informed about new technologies that are being developed and that are aimed at combating climate change. Today, we are talking about innovations happening in the nuclear power space. So in the quest for clean energy solutions, nuclear is definitely taking up the spot. And even though it's not renewable because of its limited radioactive fuel, its low carbon nature makes it one of the key players in our fight against climate change. There is a lot of talk and discussion on that. Is nuclear actually green or not? And we are definitely inviting you to join the conversation and tell us what you think in the comments below. But that aside, plenty of industries like tech or shipping are eyeing the nuclear in their mission to slash their carbon emissions. In order to broaden and deepen the story around nuclear, we invited some people who are working within this industry for quite some time now. They are J.U. and James Walker from NANO Nuclear Energy. It's a startup and they've developed an innovative tech, which is NANO Nuclear Reactor. It's a small portable nuclear reactor and they claim it's much safer to use and quite powerful. So if you want to know how our future might look like with nuclear, stay tuned to this episode. So hello, Jay and James. Welcome to the Green New Perspective podcast.
Well, thanks very much for having us.
Thanks for having us.
My first question for you, because it's a tradition here, I'm not doing an introduction for any of our guests, so I'll give you the space to do that for yourself. So the first question is to give us the overview of NANO Nuclear Energy. How did you start the company? What was your vision for the future of the company? Jay, can you start?
I'm J.U., founder and executive chairman of NANO Nuclear Energy. When I started looking into the renewables, nuclear, I kept seeing an acronym SMR, Small Modular Reactor. And that fascinated me, but I didn't know anything about it. I'm not a nuclear physicist. I'm not a scientist. I don't know anything about nuclear at the time. But I realized that, I looked at solar, I looked at wind, and to have a baseload energy that's there, you need nuclear. So what I needed is a number two, a rock star CEO. And that's what I did. I flew to Canada and I recruited my number two, my rock star CEO, James Walker. I sat there with him and I said, James, take this leap of faith with me. I think there's going to be a nuclear renaissance. I mean, I didn't really predict that, but it all happened kind of in a perfect storm now. But James said to me, I'm crazy. I left nuclear. I changed countries. I changed industries. And now you bring me back in. And I said, that's right. He took this leap of faith. And ever since then, he says to me every week, this is the best time startup he's ever been a part of. And my background is more Wall Street, capital markets and raising capital. So I needed someone who could actually translate kind of our business model, our plan, but understand what I need too, from a capital markets and business perspective. So James is kind of that perfect combination of technical and startup capital kind of IQ. And that's how kind of Nano was formed. James could talk more about now where we're heading towards.
Sure. So as Jay mentioned, I was second into the company, but my background was actually in nuclear physics and nuclear engineering already. I worked in the UK in the Ministry of Defence in the construction of facilities to build nuclear reactors for submarines, and I was seconded to Rolls-Royce, where I worked as a physicist and an engineer in the design of nuclear reactors for the next generation nuclear submarines. And I did that for quite a while until actually the nuclear energy industry looked like it was on the decline. And that's when I did move over to North America and got more involved in capital markets, IPOs, public companies, project management of those kind of those kind of industries. When Jay approached me and he was talking about nuclear, I did say there's a very high bar to entry in nuclear. It's a very capital intensive industry and there's some very well established players here. But we agreed to take this from a very objective business standpoint and look at the overall market, energy market included, and where we could fit in. And we realized very quickly that although there was a huge level of development in the small modular reactor space, in the microreactor space, the smaller version of an SMR, there actually wasn't a huge, significant amount of development. There was no licensed prototypes. Nothing had started physical test work. And so actually we thought, if we move quickly into this and we bring in some very good teams, we could actually pull out into the lead in this area of the nuclear industry very, very fast. Jay has a very well-established network, and he reached out to his contacts at University of Berkeley, University of Cambridge, and we brought on 2 scientific teams. And we gave them both the same MO. We said, we need a reactor to be fit on an ISO container, so it can be put on the back of a truck or a train or a ship and put anywhere in the world. It needs to be modular. It needs to be passively cooling. It needs to be walk away safe. And the 2 teams went away and they started engineering these 2 solutions. And they're very different solutions to how to do this, but we thought we would be in a position where we would drop one in favor of the one that looked more likely to work, but it's ended up in a situation where both have very beneficial aspects to them, where we're pursuing both now. And we're moving into a phase where we're through the design work, we're through the modeling work, and we're into the phase where we're going to be doing demonstration work, physical test work to produce the data for licensing. And that's a bit of background about how we got started, but we've diversified a lot since we started, and we can talk a bit more about that as well and some other questions.
Can you tell me, why do we need a nano-nuclear reactor?
So this goes back to why Jay and I went into this space anyway, is that when we looked at the potential energy market, we realized that there was a $1 trillion industry that was essentially untapped for nuclear, which was remote projects, remote habitation, so mining sites, oil and gas sites, potentially putting them on maritime vessels, replacing bunker fuel, charging stations for EV vehicles, charging AI centers, data centers, desalination and medical facilities in remote areas cut off from the grid systems. Essentially, it was a potentially infinite market. You could produce thousands of these a year. Even if you were just catering for island communities that run on diesel, there's still thousands of these things that could be deployed around the world to take these communities off diesel. And diesel has no rival in these areas. You cannot put wind and solar farms in there or geothermal wherever you want. These are intermittent technologies that are locationally dependent. They need good sun, they need good wind, and they also need big storage facilities for when you're not getting the drive that you need to produce that power. So diesel has gone unopposed in all of these areas for decades and decades, and no other form of energy has been able to challenge it until a microreactor has come around. And that's why we knew nuclear was a winner, why we knew the microreactors were going to be the winning solution here, that was going to really open up a huge, huge market that's never been done before.
And how much power it can supply?
So each one of our reactors is really in the region of about 4 to 5 megawatt thermal. Obviously, if you want to convert that to electric, you have some losses, but you're really looking at about 1 to 1.5 megawatt electric. So we know that industry is going to be more interested in heat, and we know that habitation, island communities are going to be more interested in electricity. So we can do both. Our analysis is probably that industry is going to be a bit more interested initially, just because the power output is a bit higher, and they need the heat for things like smeltering, steel processes, chemical manufacturing, initially where we'll go. But then we will expand fairly quickly after that to remote communities, military bases, those kind of places which need the electrical output.
And do you have any competition in the market at the moment?
There's other startups in the space as well. From capital markets and kind of investor standpoint, we wanted to separate ourselves. So we want to be vertically integrated. So we got into other things like transportation, field fabrication also. So we're thinking ahead of the game too. We're not just saying, hey, investors, we're going to spend a lot of money on building a reactor in 10 years and not provide other revenue sources. So that's a key separator between us and other startups in this space as well. So I think we're ahead of the game in that standpoint. And also it's about teams. And we feel like we have the best teams right now that could actually make this happen.
You know what I wanted to ask you, like there are many discussions about nuclear and environmental issues. So I wanted to ask you, like, what's your stance on that? Since
we obviously, being a nuclear energy company, this comes up a lot, and so Jay and I are in a position where it's very easy to just relay facts, and we just use that as our arguments. And so when people bring up things like safety, we say, if you look at deaths per gigawatt hour, it's already the safest form of energy. And these are the big civil power plants. They beat out wind, they beat out solar. They are much safer than all the other technologies out there. So nuclear energy is already the safest form of energy. And if you shrink it down to an SMR, it gets safer again. If you shrink it down to a microreactor, it's safer again. But nuclear energy suffers from misconceptions. And unfortunately, you can say the big accident disasters like Fukushima or 3 Mile Island, nobody dies in these scenarios. Unlike a big oil refinery fire or anything like that, where you can expect dozens of deaths and tens of thousands of deaths over a long period of time, or sort of an annual basis. But nuclear is already incredibly safe. And when people bring up things like waste as an example. We say, well, if you were to take all of the reactors in North America that have been operating ever since nuclear energy was introduced in the 50s, and including all the aircraft carriers and all the submarines and all the nuclear energy that's been generated. So we're talking almost 100 years of power. And you were to take all that waste and put it in one place, it still wouldn't fill a football field. That's how small the amount of waste is that is produced by nuclear power. But it still suffers from that unfortunate reputation. And nuclear has never really cared about PR, and that's to its detriment. So we can come out and just say, look, it's a zero carbon emitting energy. It's the safest form of energy. It produces the least amount of waste of any energy product out there. It's the most energy dense material in the world. Effectively, this could be the cheapest if we just mass manufacture these things and get them out there. So you could have the cheapest, cleanest, and safest form of energy there is. And that's ultimately what we want to try and do.
You mentioned safety as an issue around nuclear conversation. So I wanted to ask you, you're using uranium, right? So why uranium and not some lighter radioactive elements like thorium? Does the use of uranium raise additional safety concerns?
So uranium we know it's already the safest form of energy compared to everything else. But for instance, it's also the most proven. Like when you use thorium itself has to be irradiated to create a new isotope, which is then radioactive, which can then be used in a reactor. And unfortunately, if you're doing something like that, then say the half-life of the isotope you're creating from the thorium, which is what you actually want to get the power out, it has a very short half-life. So your actual margin for error is much worse. And like, for instance, the US has put billions of dollars into researching thorium reactors and trying to make them work in the United States because there's an abundance of thorium. And all of those experiments failed to prove economics. It's a nice idea, but uranium has a proven track record for decades across the world in multiple plants and the military too, where its vessels have been traveling across the sea for decades without incident. So you've got that versus thorium, which has no proven track record, where they've tried to make it work and the experiments have failed. And it's a much less consistent and form of energy where you need a lot more technical machinery to even make it energy producing. We're essentially sticking to what we know, and everybody else has essentially done that too. Is that if you look at all the big companies, the TerraPowers, the X Energies, everyone going into this sort of microreactor space, the Westinghouses, they're all going for uranium as well, and that's not an accident. That's because it's the best form of energy we know of.
You mentioned like meltdown risks, things like that, and I have to talk about that because I know that people are going to, raise questions around that. So I'm spending a bit more time asking you pretty much the same types of questions. But are there any meltdown risks? How does reactor works, and how is it safer than conventional uranium reactors? Because, like you said, people are imagining some of the famous nuclear catastrophes.
Yeah. So just to start with the big civil power plants. The ones we've all seen across the world now since the 50s. It's also a misconception that those things can blow up. They can't. Like you can't turn the uranium in a conventional civil power plant nuclear reactor into a bomb. It doesn't work that way. It needs to be enriched something like 10 times as much before it even becomes explosive. So you can't get a nuclear explosion from a nuclear power plant. I think if anyone's ever seen an explosion from a nuclear power plant, that's the hydrogen, and that's a pressure thing. So the hydrogen blows up, but the nuclear fuel itself cannot. Worst accident scenario that can happen with a big civil power plant is that if the coolant leaks out, it can overheat and then it can melt. No one's going to die in that kind of scenario, but you're going to have a situation where you're going to have a cleanup operation. You're going to have to keep it cool and separate the material and then put it into waste storage. If you go to an SMR, it gets even safer still. So you have fewer mechanical components, you can have fewer things that can actually go wrong. And if you go to a microreactor, it becomes even safer still. If every component breaks in a microreactor, it doesn't matter. It doesn't have enough fuel to overheat to melt the reactor. So it just sits there passively cooling. The big civil power plants are already the safest form of energy, beating out wind and solar. SMRs are safer still. Microreactors, there's very little that can go wrong. Even if you were to fly a a big missile into a nuclear reactor, a microreactor, it actually becomes less dangerous because the way nuclear criticality and reactivity works is if you push more fuel together, it reacts with itself. If you actually separate it, it gets cooler and it gets less radioactive. So if you want to blow it up, great. You'll just have to pick up all the stuff and it's just a cleanup operation. If you leave it alone, it will just passively cool. So there's very little failure mechanisms that can actually go wrong with the microreactor.
And did you have any marketing campaigns, communications campaigns explaining how the tech works? and basically all the inventions so far.
We talked to a lot of, podcasts, and we've done a lot of interviews on TV. I think we've educated a lot on our side. We continue to educate viewers and people who are interested in kind of the new advanced nuclear technologies that are coming up, like nano nuclear. So we're constantly educating, and like James said, there's just so much to do. And what James said before, in terms of just nuclear has had bad PR in the past, and we're here to kind of assist that and change the viewers' kind of minds on what actually nuclear energy is and how safe it is, and our technology is even safer than the safest energy
Yeah.
out there.
And what are some of the biggest milestones that you have so far with the company?
Some of the biggest milestones would be our seed investment was taken out by investors who are executives of the largest transportation company in the world, because they saw kind of our vision on how to transport these nuclear batteries, you could say, throughout the world. So they actually really loved that. We also had other milestones like engaging with Idaho National Labs to rip apart kind of our reactor designs and to do an audit. I think we're probably the only company that's done that, to show transparency to the public that we're not just talking about it, we're actually making this happen. And we're having a third party kind of confirm all of this too, not just us saying, hey, we're building something great, but we're actually having, a government entity helping us say that as well. Showing transparency, obviously de-risking the company and layering in other businesses besides reactor business. That's key too for us. And then we have other big milestones we're planning to announce in the next few months. So you just have to wait for that.
How did you pick your team, since this is a new thing, except for James? We know about James.
Oh, how do we pick? It's very easy. We just look for the number one people in the world. That's pretty much it. When we need help or we have a deficiency in a certain area, then we try to go after the best qualified individual or professional in that area. So if we need someone in military, we go after someone in military. If we need somebody who is a former Secretary of Energy of the United States, then we try to do that. So we try to fill in the gaps. But number one is actually our nuclear engineers, who are the scientists and the backbone of the company that are creating our proprietary reactor designs. Those are the key kind of people and teams that we actually focus on, and we want to complement them and build more and more quality people around them and surround them with the best.
And did you have any challenges in motivating the team, since this is a really fast-paced industry and a lot of things are changing all the time?
It's not that hard right now to motivate the team when we have so much momentum in the space. There's a real nuclear renaissance happening, and with COP28, dozens of countries getting to tripling nuclear energy by 2050. I think there's a lot of room, and there's a catalyst for the next 26 years.
And you've mentioned you have other innovations and offerings, so can you tell me a bit more about that?
We're planning to announce more, but
But it's a
one
secret?
that we I mean, I won't say it's a secret, but we're planning to announce a lot of new things coming up. But one that we've been public about is our subsidiary Halu Energy Fuel, which we're planning to again focus on getting fuel for our reactors in the future.
What trends are you most excited about in the nuclear sector? How do you feel the industry is going to evolve in the next, let's say, 5 to 10 years?
I think I'd say that the potential for it is so enormous that like what we really want to get into is first of all remote industrial projects or the mining sites, things we talked about like that. But there's really no shortage of areas we want to expand into. We were even talking about space programs, powering vessels with some of our reactors, getting involved in maritime industry to replace bunker fuel. We're speaking to AI and data centers about powering remote tech centers. Really, there's so much blue sky potential here. Is that, and we're speaking to so many different groups that are interested in this, and these are the big tech companies too, sort of the Microsofts of the world, who are moving in the nuclear direction now because they want to be able to power their big operations, and they want to do it in a green way. And this is the only solution they've got available to them. So they're moving into this space too. So you can see the sort of convergence of industry and government pushing this sort of nuclear renaissance to happen. So all we're seeing at the moment is positive sentiment from industry and government, and even the public sentiment is improving quite rapidly. I think it's the best it's ever been. By the end of this decade, by the end of the 20s, you'll see SMRs being deployed. Beginning of the 2030s, you'll see microreactors being more widely deployed in much greater numbers around the world. And maybe island communities, remote habitation, all of those sort of areas will be looking to then replace diesel generators with smaller footprinted microreactors, so they don't have to consider regular importation of diesel to their communities. That'll be a big one as well.
And Jay, what advice would you give to other startup leaders or people who want to get into nuclear, not just nuclear, basically everywhere within the clean tech?
Oh, I think this is the greatest time ever to start a clean tech company. There's so much funding opportunities now, especially in nuclear. The governments are handing out grants. There's a lot of VC companies now trying to get in early on clean techs. Funny thing is, when we started, me and James, we pitched a ton of a ton of VCs and even large institutional banks, and they all loved the story. They all loved what we're doing, but we were really early. But now we've kind of grown into this space, and now they're all coming back to us. Recently, one of the largest investment banks that done a lot of these IPOs and for nuclear tech, came to us and was wanting to initiate coverage on us, which is to me and James, that was like a wow moment because we were the ones chasing them, and now they're chasing us. So that's a good feeling to have. But I would just say for people who are hesitant to even start tech or even a nuclear company, you should just take the risk now. Don't wait till you're old and gray, and just take the leap of faith like I did with James, I would say.
And a question for you both, for people who want to gain like further knowledge about the nuclear energy and about what you're doing. Do you have some communities to share, maybe LinkedIn pages? Where can people find more about you, more knowledge about nuclear, how they can join the communities? Some.
Sure. Yeah, no, they could follow us on social media. We've built a cult following, so they can follow us on Twitter, on LinkedIn. Those are the two platforms where we're very aggressive in promoting us. But we have a ton of editorial pieces being written about us just because everyone's fascinated with what we're doing, and building a prototype's never been done before in humanity. So right now, this is the perfect time to just follow what we're doing, and like I said, there's a lot of big milestones coming up, so you want to stay tuned.
So when do you feel that the prototype is going to become a product?
So yeah,
James can
I
answer
would
that.
say, and this is probably going for all microreactors at the moment. Ours has finished the design phase. We're looking now to build a testbed reactor site. And what that is a place where we can start doing physical demonstration work, physical tests, so we can acquire the data to go to the licensing process. That'll take us about a couple of years, and we'll start sometime around about 2026, hopefully. The licensing process for a reactor is a fairly long one. That's really going to be between 3 and 4 years. And that takes us right out to about 2030. And then at that point, I would say us and probably a few other microreactor companies will be ready to have a commercial product that's ready to go to market. And the idea will be that it can deploy anywhere. So it won't need site-specific licensing. It can just, provided it meets the destination site meets certain criteria, it'll be able to deploy there. And then we want to roll out hundreds of these things out of the door. Small little nuclear batteries to replace diesel generators.
Thank you. Thank you both. We hopefully gave some introduction to our audience how nano-nuclear reactors work and what's going to happen in the nuclear space in the next couple of years. Thank you once again for being a part of the Green New Perspective podcast.
Thanks for having us.
Thank you so much.
This is the end of another episode of the Green New Perspective podcast. Thank you for tuning in and sticking with us. This episode is proudly sponsored by New Perspective, a Boston-based marketing agency working with clean tech companies. So if you need a help in your marketing services, please check out the info on our sponsor in the description of this episode. And if you want to support what we're doing, you can consider liking, subscribing, and tuning in again to one of our podcast episodes on your favorite streaming platforms. We are everywhere. We are on YouTube, on Spotify, on Zencaster, on Apple Podcasts, basically whatever you're streaming your podcast. So yeah, that's it for me for this episode, and hopefully I'll see you in the next one. Bye.